Welcome back to Chapter 6, Part 3. When we last left off, I told you we would talk about loops and how to process files. So it's really common when you are reading data in from a file that data is separated with the new line character. So when you want to read data in, you're going to want to read it usually line by line. To do this, the idea is to sit in a loop and read the line over and over again. So often the number of items stored in the file is unknown. We don't know how many items are in the file. Because of that, we want to write a loop that's known as the while loop. So in this case, we're saying while the line of information that we're reading, so we're going to use the read line, and we're going to, whatever comes in from the read line, we're going to put into the variable line. And as long as the line is not equal to empty string, keep going. So this looks like this. The first thing we do is we open the file. So that's step 1. Then we're going to sit in a loop, and we're going to say, first, use the read line to read the first line. This, by the way, is known as priming the loop. So you're always going to have this first read, then you go into the loop and you read each line until you get to no more strings. So you get that empty string, which is a true. And then you want to make sure, remember that last step, to close the file. So this is step 2, and then step 3. Now we can also use Python's for loop to read lines. We just talked about using the while loop. Now let's use Python's for loop. Python allows a programmer to write a for loop that automatically reads lines in a file and stops when the end of file is reached. To do this, we're going to use the for keyword. Line is our variable, this nifty little in statement, and our file object. Remember our file object from previous when we did the open? And then when we do that, everything that gets read from this line, we can then do stuff on in the for statement. All of our statements are in under the for loop. Again, this is going to be indented by 1 level. So let me write that out here. This is indented 1 level. If I can get my pen together, there we go, indented 1 level. And the loop continues to iterate once over each line in the file, and when it's done, it comes out of the for loop. Oftentimes, when we're reading data from a file, we're actually reading data as records. So each record is a set of data that describes one item. Let's take, for example, a shopping list. Let's say you bought 3 items and we have a record. The first field of that record, and here's that word field, which is a single piece of data within a record, is the ID of that item. Let's say it's 2. And then we might have the description of that item. We'll say broom. And maybe the third field we have is quantity. How many do we have on hand? We got 3. This entire piece of data is known as a record. Each piece of data, all these are known as fields. We can read these records using sequential access by reading each field until the record is complete. When we're working with records, it is also important to be able to add records. We have to be able to display the records, search for specific records, modify records, and delete records. All these items is exactly what you need to work on records within a database, whether it be a flat file database, whether it be anything that's a record. It's important now that we're starting to get into some more complicated, more advanced items in programming. You talk about exceptions. An exception is an error that occurs while a program is running. Now, we have seen, and we've even talked about, two types of errors. The first type of error is that syntax error, and that error is told to you when you go to try to run a program. It'll say, oh, nope, can't run this program because you have a mistake. An exception is an error that occurs, and it's important, is while a program is running. So once you get the program running, if an error occurs, you are now seeing an exception. And most of the time, it will cause your program to abruptly halt, and you'll get that nice set of red text letters known as the traceback. This is the error message that gives the information regarding what line and what caused the exception. As I've told you before, sometimes those errors are a little muddy and convoluted. You get better at reading those as you do it. But it should indicate the type of exception, give you a brief description of the error that caused the exception to be raised, and hopefully it might even give you the line number where the error actually occurred. Sometimes I've seen it where it gives you the line number below or above where the error actually is occurring. But again, as you get good at reading exceptions, you'll read that. So exceptions. Many exceptions can be prevented by careful coding, but I will tell you, don't get in the habit of trying to spend so much time programming that you never have an exception occur. It happens, and we catch it in testing. But if we are careful with the way we write our code, and the example here is we're going to validate input, right? We want to make sure that before we try to make use of a number that a user typed in, that it actually is a number and not some characters that they typed in. So this usually involves a simple decision construct. We're going to look to see, did the person enter in the right type of input? Some exceptions cannot be avoided no matter how careful your coding is. Trying to convert non-numeric strings to an integer, again, if this happens, is usually, again, which is interesting because this usually happens because something went wrong with either the input wasn't incorrect, it was incorrect, we didn't validate the input from the user, or maybe we're getting input from a file and where we thought we would have a number or a string, it's the opposite. So another type of exception, though, that can't be avoided is when we're opening a file to read it. What if we go to open a file to read it and it doesn't exist? Maybe we wrote a file somewhere in a previous program, and the user goes and runs our other program that reads that file, and for whatever reason, maybe they deleted it. Maybe the operating system had a disk error and it didn't write it. This is an example of an exception that probably can't be avoided, no matter how careful we code. And that's the point of exceptions. We want to write what's known as an exception handler that is essentially there to catch errors as they happen. So it's code that responds when exceptions are raised and prevents the program from crashing. In Python, we use what's known as a try except statement. So the general format of a try except is you first type the try and then tab in and write all of your statements. And then you're going to have the except. We're going to tell it what exception name, because a block of code could throw different types of exception. So this allows us to catch different types of exceptions and then write it out or make use of that in our statements to do some kind of code to gracefully handle that exception. So in this, the try suite, it's the statements that can potentially raise an exception. Now again, they didn't do a good job on this slide of indenting, but essentially these statements are the try suite. That's all the statements that could potentially raise an exception. Good examples of this would be opening and reading content from a file. The except statements, all the statements that are under the except, are known as the handler. These are the statements contained in the except block. If statements in the try suite raises an exception, the exception specified in the except clause will run that handler's immediate code. So the handler is immediately following the except clause executes. Up here, we talked about this. This is the exception name. And if whatever happened in these statements matches this exception name, then this handler is going to run. Other exceptions. If we don't have something to handle that specific exception, then the program will halt and it'll throw that red set of text. It's known as that traceback error message. Now, hopefully, the idea here is we write all this so that way when this code runs, let me erase all this so we can read it again. When this code runs, this statement, we really do hope that nothing happens, no exceptions get called. And if no exception is raised, all the handlers are skipped. Now, you probably heard me say in that last statement that all the handlers get skipped. And that's because we can have multiple exceptions. We can look for different types of exceptions. And we're going to look down here in a moment to see some different types of exceptions. So why do we want to have multiple exceptions? I know you're just dying to know. Well, often code that's in one of our try suites could throw one or more types of exceptions. So we need to write an except clause for each type of exception that needs to be handled. An except clause that does not list a specific exception will handle any exception that is raised in the try suite. Now, it is important to know we should always try to catch the specific except. And that's because, for example, up in here in our statement, if an error were to occur while opening the file, we may want to handle it one certain way. Or if the error happens while reading the file, we might handle that differently. So that's why we would have different excepts. But finally, we could put an except block that has no exception name. So it's like that. And this handler would run if no other except got caught. Now, when you don't have an except and you're not looking to catch an exception, and we've seen that before, where we're running code and all of a sudden it spits out all that red text, also known as the where'd it go? I just had it. The traceback. It has the traceback. So that red code is known as a traceback. It's the error message. That red code, if we don't have a handler to handle it, gets thrown. But it's also still a part of the except. So exception object, remember we talked about we had a file object? Well, now we have, if an exception gets thrown, an exception object is created in memory for us to use. So usually that exception object is going to contain that default error message, that red text that is the message of why that error occurred. We can assign that exception object to a variable and an except clause. We can also print it out to the screen. And this is what we're talking about. We can pass that exception object variable to the print function to display the default error. So one of the errors that they're showing here is known as a value, come on, Ben, value error as error. That's a type of an exception. With the try except statement, there is also the ability to add an else clause, which appears after all the except clauses. It's aligned with the try and except, so what they're saying here is if I have a try and I have an except, these all line up on the same tab. And the same thing is if I add an else, it too aligns on that same tab line. And the syntax is similar to the else clause back in our decisions, our if else statements. The else suite block of statement executes after statements in the try suite only if no exceptions were raised. So what does that mean? Imagine this. You want to write a piece of code. You want to open a file. Well, you know that once that file opens, you have to close it too. So you might say try and then put in here all the code for opening and reading from a file. You're going to then do an except in case that file isn't able to open. And then maybe we do another except, so that particular error type. And we do another except for if we can't read the file. And then we have just a blank except to catch all other errors. But then we know if no error occurs, then we need to close that file. So this says, hey, do all this code. If any of these errors happen, okay, that's fine. Deal with them. But if no errors occur, make sure you do this else. And then if the try except clause was not difficult enough, we know we can do the try. We can do an except. We've talked about an else. We can also add a finally clause. The block of statements after the finally clause will execute whether an exception occurs or not. This is definitely to clean up. Oftentimes it's used to clean up before your program exits. So we've got the try. That is all our code that we want to run. Then we have the excepts for anything, any errors that may occur. Then we have the else, which says, hey, if no errors occur, run this. And now we have a finally, which says no matter what, whether an error occurs or not, run this code. So what happens if an exception is not handled? Well, two ways for exceptions to go unhandled. We don't have an except clause for that specific exception. We don't have one that is the right type. And we didn't raise a default exception, which is that exception without a type. And then something happens in the code. In both cases, the exception will cause the program to halt. Python documents provides information about the different types of exceptions that can be raised by different functions. If you don't handle an exception and something happens, you're going to get that red code, that traceback code, written out to the console like you've seen before. So in this chapter, we covered the types of files and how we access those files. We talked a little bit about file names and file objects. You need that file object to do stuff with the file. We talked about writing data to a file in both the write mode and the append mode. We know how to read data from a file, and we know how to determine when the end of file is reached. We also talked about the new line character, which also helps us with the processing of records. And then finally, we talked about exceptions and whether we can have traceback messages or handling of exceptions. I hope you got an awful lot out of this couple of videos. Make sure you go through the chapter. There's lots of examples. Read through the book. Do a lot of the practices. Even some of the examples, I do recommend, even though you have it in front of you, type it out too. And as you're typing it, make sure you are absorbing what you're typing and saying, oh, I'm writing this because this is what it's going to do. And play with it. Add things, take things away, break it, fix it. That's the only way you're going to get through learning how to read and write from files, especially when we start talking about some records. Thank you so much for watching these videos, and I look forward to talking to you soon.